Hey everyone, and welcome. We're about to jump headfirst into the world of big data analytics. And yeah, I know, it can sound pretty intimidating, but I promise we're going to break it all down. We'll look at the seriously cool tools built to handle just insane amounts of data, and more importantly, how all that information gets turned into real, meaningful action. All right, let's get into it. So let's kick things off with the big question, the one that started this whole revolution. For the longest time, our systems for storing data worked just fine. But then, the world changed. The internet, smartphones, social media, suddenly data wasn't just neat and tidy anymore. It was a flood, a total deluge coming from every click, every like, every single sensor out there. So what was it about this flood that just shattered our old reliable systems? And this lays out the battle perfectly. On one side, you've got your traditional databases. You can think of them like a very strict librarian. Everything has to be perfectly categorized and fit onto a specific index card before it can be filed. They're super reliable, but they're designed to run on one single, really powerful server. We call that vertical scaling. But the new world of big data, it's messy, it's fast, it needs flexibility, it needs to spread the work across tons of cheaper computers all working together. That's horizontal scaling. The old model it just couldn't hang. So because the old tools broke, we had to invent new ones. A whole new toolkit, really. A generation of databases engineered from the ground up for a completely different kind of challenge. One defined by unbelievable volume, breakneck speed, and wild variety. I love this analogy because it just clicks. Using a traditional database for today's data is like taking that old library card catalog into a massive chaotic warehouse that's filled with everything you can possibly imagine. It's just not going to work, right? You need something totally different. You need a magic search box that can find anything, anywhere, no matter its shape or size. And that, right there, is the whole idea behind NoSQL databases. Now, this magic search box isn't just one thing. It comes in a few different flavors, each one designed for a specific job. You've got key value stores, which are wicked fast for simple things like looking up your profile on a website. Document stores are fantastic for more complex but flexible data, like all the parts of a blog post. Column family stores are the heavy lifters, built for absolutely gigantic data sets. And then you have graph databases, which are genius at understanding connections, like figuring out social networks or spotting complex fraud rings. Okay, let's zone in on a few of the big players here. You've got HBase, which is a total beast when you have these huge, sprawling tables where most of the entries are actually empty. It's built right on top of Hadoop's file system. Then you've got Cassandra. Its superpower is being always on, never failing. It's designed so that if one computer goes down, the system doesn't even blink. Perfect for stuff like IoT devices, constantly sending data. And of course, there's MongoDB. Probably the most famous for its flexibility, because it lets developers work with data in a way that feels really natural to them. So you might be thinking, this is all great, but what if I spent years learning SQL to talk to databases? Well, the community thought of that. That's where a tool like Apache Hive comes into play. Think of it as a universal translator. It lets you write something that looks and feels a lot like the SQL you already know, but it runs your questions across these enormous distributed datasets. It's a bridge from the old world to the new. All right. So we've got the tools to store and find all this data. But honestly, that's just step one. Storing data is useless if you don't do anything with it. The real magic, the real value, happens when we start asking questions. And we can think about this process as climbing a ladder, where every step up gives us a much more powerful view. And here it is, what we call the analytics ladder. It's so simple, but so powerful. It all starts with the most basic question: what happened? Then you climb a rung and ask, okay, why did it happen? From there, you look to the future. What will happen? And you reach the top with the most important question of all. What should we do about it? See how each step builds on the last? So that first rung is descriptive analytics. This is probably the one you're most familiar with. It's the foundation. It's your company's weekly sales report. It's the dashboard showing website visitors. It's all about summarizing the past in a way that's easy to understand. It's looking in the rearview mirror. Okay, let's climb up. Now that we know what happened, we get to play detective. This is diagnostic analytics, and the keyword here is why. Why were sales down in the Northeast last quarter? Why did that one social media post go viral? This is where you dig into the data, you look for patterns, you try to find the root cause of what you're seeing. Now we're getting into some really cool stuff. Rung 3 is predictive analytics. We're officially turning around and looking through the windshield instead of the rearview mirror. We use all that historical data to train statistical models and machine learning algorithms to make educated guesses about the future. Things like which customers are most likely to leave, or what sales are going to look like next month. And finally, we reach the top of the ladder, prescriptive analytics. This is the real game changer. It takes that prediction, say, this customer is probably going to cancel their subscription, and it goes one step further. It recommends an action to change that future. It might say, so you should offer that specific customer a 20% discount. It's not just about seeing the future, it's about actively trying to make it better. And hey, besides that main ladder, there are a couple of other specialized types worth knowing. Stream analytics is all about analyzing data the very second it's created. We're talking real-time stuff, like spotting credit card fraud as it happens. Then there's location analytics, which is all about geography, using maps and spatial data to optimize everything from delivery routes for a package to where a city should put a new park. So, we've got the tools, we've got the ladder of insight. That's all great in theory. But now let's get real. Let's look at how all these concepts come together to power things you use every single day, often without even realizing it. Okay, just think about the last time you bought a coffee or paid for gas. The second you tapped your card or phone, a whole world of high-speed analytics kicked into gear just to keep your money safe. And to get a sense of the scale here, just look at this number. Visa has to handle more than 65,000 transactions every single second. That is just mind-boggling. In the few seconds it took me to say that, we're talking about hundreds of thousands of transactions. There's no way a human could ever keep up. This is a problem that only big data can solve. So how on earth do they do it? Well, it's a textbook case of stream analytics. In real time, your transaction is compared against your normal spending patterns and millions of known fraud patterns. The system is looking for anything weird, any anomaly, and it has to make that decision, fraud or not, in the fraction of a second before the little machine on the counter says approved. It's incredible. All right, next up, retail. Have you ever been shopping online and it just feels like the website knows you? Like it knows exactly what you're looking for? Well, that's not a coincidence. That is big data at work. Big retailers are basically climbing that entire analytics ladder all at once. They look at your past purchases and what you're clicking on right now. That's the descriptive part. They feed that into predictive models that power those people who bought this also bought recommendations. And then they go full prescriptive, using all that sales data to figure out exactly how much inventory to stock and where to put it to get it to you faster. But maybe the most important and awe-inspiring use of all this is in healthcare. This is where analytics isn't just about convenience or profit. It's literally about saving lives. It's helping medicine shift from just treating sickness to actively preventing it. Think about it. By analyzing millions of health records, plus real-time data from things like smartwatches, predictive models can flag people who are at a high risk for a disease way before they even feel sick. That allows doctors to step in early. And then, on the prescriptive side, they can use a person's unique data to design a treatment plan that's tailored just for them, not just some one-size-fits-all approach. So you see, it's everywhere. From how you pay for things, to the ads you see, to the future of your own health. The tools and the methods that we've just walked through are fundamentally changing the world by turning all that chaotic noise of data into something clear, insightful, and actionable. At the end of the day, after talking about all these complex databases and algorithms, what's the one thing you should really remember? It's this. The technology. It's amazing, but it's just a tool. The real power, the true revolution of big data, isn't about just hoarding mountains of information. It's about how it allows us as humans to get more curious and to ask better, smarter, more powerful questions than we ever could before. These tools are out there. The data is all around us. The real challenge now, and the biggest opportunity for all of us, is to think about what problems we want to solve. What mysteries do we want to unravel? So I'll leave you with this. What question will you ask?